A high energy photon with a wavelength of 3.84 femtometers. Okay, so first prize if you realize that the wavelength is 3.84 times 10 to the minus 15th meters, right? And you can look those up. You can always look up those metric prefixes, nano, micro, femto, pico. All of those things are in the front of the data packet, so you don't have to panic. But just look for them, right? That little F can slip off, right? And then I think without that it becomes like FM, like radio waves or something like that. Okay, let's see. You can create a muon anti-muon pair, each with 56 MeV of kinetic energy, right? Show that the rest mass of a muon is approximately 106 MeV, okay? There's a couple ways to do this, right? One way is to figure out that, two of these and two of these has an energy that's equal to this wavelength or so. I'm just going to calculate the kinetic energy, right? So here, this is very much like the photoelectric effect, right? The photon energy turns into the rest mass of a muon, right? And a anti-muon, right? Plus the kinetic energy of the muons, right? So it's going to be 56 for that guy and 56 for this guy, right? Okay. So let's figure out the photon energy, right? The photon energy is going to be, let's calculate this. Let's see, energy is hc over lambda, right? So that's going to be 6.63 times 10 to the minus 34th times 3, and that's joule seconds, right? Times 3.00 times 10 to the 8th, and that's meters per second. And then we're going to divide by that wavelength. So 3.84 times 10 to the negative 15th, okay? So this is going to give us our energy, but of course it's going to be in joules, right? Because this is meters and the units are going to cancel out here. So 6.63 times 10 to the minus 34th times 3 times 10 to the 8th divided by 3.84 times 10 to the minus 15th is I get 5.1796 times 10 to the negative 11th, and that's joules, right? So now let's divide by 1.6 e minus 19th, and we're going to get, this will give us electron volts, right? And we get a big number, which I'm going to divide by 1,000,000. So divided by 1 times 10 to the 6th, right? So, and then divide by 1e6, right? And now I've got a lot of MeV, so 323.73 MeV, right? So now we got to balance this equation. This guy's got a whopping, don't get hit by this photon, right? 323.73 MeV turns into the rest mass of these plus, let's see, twice 56 is 112, right? Okay, so 2 times what? Plus 112, right? I don't know if this equation kind of is dodgy. We'll put a box around it. Okay, so this much energy turns into 2, because remember you have to create the particle and the antiparticle, right? And then you need a total of 112 MeV left over, right? So all I do is I go 323, I go subtract 112, right? And I get 211.73, and then I have to divide that by 2. And I get 105.86, right? So question mark is 105.86, which is approximately 106 MeV, which is what it asks us to do, right? I kind of like those problems where they tell you what the answer is and you just need to show it. Okay, just make sure you show all the steps. And then for these types of problems, I'll also show the answer, because oftentimes, remember, the mark scheme says that you need to show more precision. right? So show the results of your calculation, then show it properly rounded, say, which is approximately 106. Okay. Anyway, I think you've done these before, so this shouldn't be too hard.